Welcome to the students. Good evening. This is from Rangaraju, Yupp Master. Today we are going to discuss the previous examination paper which was held on Saturday. We are going to discuss about that shortcuts and what are the possibilities to save the time. Let us see that. This is very important. While you are solving the problem, you must save the time while looking into the options, and sometimes you are going to look into the diagrams and you have to decide. Yeah, please have a look. Please have a look. The bending of light rays because of change of medium is called. Generally, if you are going to have a look into the matter of bending of light rays, so the bending of light rays is the phenomenon of refraction. Suppose if you have taken that two medium, first medium and second medium, whenever light is allowed to enter from one medium to another medium, that is from rarer medium to denser medium or denser medium to rarer medium. So, the bending, there exists a bending of light rays. The common phenomena which has been observed is bending of light rays. So, whenever you will allow the light rays which are going to pass from air to water or water to air, so the phenomena of bending exists. So, the angle of refraction is going to be more sometimes the angle of refraction is going to be less. So, depending of the medium, depending on the density of the medium, so you compare rarer and denser. Here simply the bending of light ray because of change of medium is called interference, reflection, refraction and modulation. The possibility is third option. Yeah, we have to take this is the correct answer. Refraction is the phenomena. At the same time, you can remember one important point. The refraction is the phenomenon which was related to the two media. While you are going to take that reflection, it related to one medium. Just you have to take that from the surface of the medium, there exists a reflection of light rays. So, refraction is related to two media. That is, if you are going to extend the refraction, it is going to third medium also, whenever it is going to enter from air to water, water to glass, like that. The refraction is the only phenomena which is related to more than two also. Yes. So, shall I go for the next question? Please have a look. When the light is refracted, which of the following does not change? Yeah, this is a really good question. So, frequently in entrance examinations also they are going to ask these type of the questions which are going to making somewhat tough. Yeah, please have a look. Whenever a light rays are entered from one medium to another medium, what happened? Let us see. So, light is the form of wave. So, light possesses the dual nature, wave nature and particle nature. They are going to travel from one medium to another medium in the form of waves. If you are going to talk about that frequency, the frequency of a medium depend on the source which generates the light. So, the number of oscillations made per 1 second is known as frequency. So, light is traveling in the form of wave. Let us have a look. Yeah, if you are going to have a look, please take that. You can take that. Whenever light is traveling in the form of wave, yes, if you want to take that, actually it has been shown that in the form of diagram. Yeah, you can take this. Actually, which happen whenever light enters from one medium to another medium. Yeah, it's going to be refracted. Yes. Yes, from the point, have you seen this diagram? First one, this is known as incidented light. We are going to take that, this is the I and R. Whenever you have taken that first diagram in the form of ray, whenever you have taken this diagram, it is in the form of wave. So, there is a possibility to show that the light is travelling in the form of wave as well as in the form of particle. So, you have to confirm the dual nature, light possesses the dual nature. In the higher classes you should learn. Now, if you are going to take that, this is the light wave. Let us take that the frequency of incident light ray is going to be nu. The frequency is going to be nu. Whenever it enters from, this is a rarer medium, this is a denser medium, whenever the light enters from rarer medium to denser medium, let us talk about that what are the changes that can occur. You can take that, if you are going to look into the matter of the frequency, first we have to take that the frequency nu of incident light ray. After the refraction, it will enters into the one medium to another medium. So, it is going to bend, this is the normal, towards the normal as compared to the rarer and denser. Whenever it is entered from rarer to denser, it is going to bend towards the normal, that is a separate case. Now, we are talking about that what are the phenomena that changes when light allowed to enter from one medium to another medium. So, let us talk about its wavelength. It is going to be lambda, it is going to be lambda dash. Here I am going to take that nu, frequency remains same, lambda and lambda dash. There exists a change in wavelength. Whenever light enters from one medium to another medium, the phenomena of wavelength changes. If the wavelength changes, lambda changes, then if lambda changes, V also changes, This is the case we have to confirm. Now, if you are going to look into the matter of these wavelength and velocity and amplitude, all are going to be changed, but frequency, here we are talking about that frequency, it remains same. If there exists a change in the energy, let us talk, that leads to the change in momentum. Suppose if you are going to take that m is going to be constant and velocity is going to be changes. If you are going to take that photon, light is nothing but photon. So, you are going to consider the momentum will changes surely. Now, the frequency remains same. You are going to take that in this region, in this region the number of cycles per one time, the number of cycles per time t. Here also the number of cycles per time, both are equal. What is the frequency? The number of oscillations made in 1 second is known as frequency. Before entering, after entering into the another medium, these are same. So, frequency does not changes. The frequency of the light wave can be changed by the source only. So, the frequency depend on the source only. It does not change by the medium. So, very simple. It is very important to discuss that what are the existing phenomena when light is entering from one medium to another medium. So, frequency remains same, frequency remains unchanged. So, wavelength, velocity, amplitude, maximum displacement, it can be changed, but the number of cycles made in 1 second does not changes. So, it is the important property. Frequency does not changes. So, when light is refracted, which of the following does not change? Wavelength changes, velocity changes, amplitude changes, but the frequency remains same. Please remember that this is very important point even for higher competitive examinations also, right. Let us go for the second question. Due to the refraction, the bottom of swimming pool appears dash than the actual depth. What happened when you are going to consider the phenomena of refraction? Due to that, the bottom of the swimming pool is going to be appeared raised than actual height. So, here you are going to consider that you are going to consider, yeah, this is the actual height, it is going to be raised, this is the actual depth d. So, it is going to be identified that d dash. So, you are going to consider d is the actual depth and d dash is the apparent depth. What happened? Due to the refraction, the bottom of the swimming pool is going to be raised. So that if you are going to have a look into the matter, deeper, shallower, both A and B actual. So, due to the phenomena of refraction, it is going to be raised, it is going to be appeared raised. Say, if the actual depth is going to be 100 meters, suppose if you are going to take that 100 centimeters, it appears like 90 centimeters. So, sometimes the actual depth is going to be identified and the apparent depth is also identified. You need to identify that lateral displacement. So, this is very important. Please consider, due to the phenomena of refraction, the bottom of the swimming pool is going to be appeared shallower, it is going to be raised, very simple. Yeah, it is a very easy question. Please have a look. Right, let's go for another question. Yeah, light bends in all materials at dash angle. This is a important question. So, if you have considered the refraction phenomena, the bending of light rays whenever they are entering from one medium to another medium are known as refraction. If you have taken that the bending is same or different or nearly same or opposite, whatever, if you are going to take that all the materials are having the same density, all the materials are having the same density, say yes or no? No, because the composition of the atoms, the number of atoms per unit volume are going to be different. If you are going to take that water and glass, quartz, diamond, different materials are there, different transparent materials are there. While you are talking about that light, you have to consider the transparent substances. So, they are having the density, different density. Now, if you are going to talk about that bending, while you are going to take that bending of light ray, if you are going to take that, whenever you have taken that bending of light ray, yeah, you have to consider bending of light ray is the phenomenon, it is the refraction. Bending of light ray is nothing but refraction. Yes. Now, if you are going to have a look into the two cases. So, yes, you have taken, this is the case, you have taken another case. Yeah, this is the first one, let us assume this is the second one. Now, for example, if you are going to observe, whenever the light enters from air medium to, this is the air medium, let us assume this is a glass, yes, air medium to glass medium. So, the incidented light ray, if you are going to have a look, yeah, the incident light ray which is going to be refracted, yeah, this is the normal which we are going to take that. When you have taken that, the light ray enters from, this is the glass, this is the air, if you are going to take that. What happened? Let us see. Yeah, you have to take that. This is the normal. Here, what I am going to discuss with you, I am going to look into the matter of the light rays are going to be entered from air medium to denser medium, that is glass medium. Simultaneously, glass medium to, the light rays are entered from glass medium to air medium or any other medium you will consider. For the case study, we are going to take that glass to air, what happened. So, here let us assume this is the theta 1, yeah, this is going to be theta r, angle of refraction, this is theta I. You have to consider theta I. Theta I is the angle of incidence, theta r is the angle of refraction. Now, here we are going to talk about that, yeah. Whenever light enters from glass to air, please have a look. Yeah, we are going to take about that theta I and theta r. If you are going to, it's move away from the normal. Here the refracted light ray has shown, first is a small angle of refraction, angle of bending. Second one, it is moving away from the normal. So, whenever light enters from glass to air, so simply you are going to talk about that. Whenever the light ray enters from rarer medium to denser medium, it bends towards normal. Let us assume the angle of bending is going to be theta 1. At the same time, the light ray enters from denser medium to rarer medium, glass to air. It moves away from the normal. Here what happened, the refraction angle is going to be more. Here the refraction angle is different, here the refraction angle is different. What can you conclude with these two case studies, first and second one? Same angle or a different angle, nearly same angle or opposite angle. So, you can simply conclude the matter, the light enters from air to water, it is going to be having that small. While you are going to take the measurement of angle of incidence and angle of refraction, normal is the only one reference. At the point of contact, you can consider, this is a C, this is also C. At the point of contact from the transparent surface, you can take that if the light ray is moving towards the normal, if the light ray is moving away from the normal. Here the angle of refraction, the bending, if you are going to take the term bending, which can relate it to the angle of refraction. So, here small, here large, it is very simple and important topic. If you are going to take the question, light bends in all materials at, simple question they have given, but behind that you have to understood the case 1 and the case 2, then only you can give the answer. It is very clear. So, finally, we will conclude that matter. Whenever light enters from one medium to another medium, it is going to bending to exhibit the phenomena of refraction. So, no doubt at all, but all the materials are having the same composition? No. All the materials are same density? Now, one important point, if the light enters from one medium to another medium, which are having the same density, is there exist a bending? The common observation, whenever light is allowed to enter from medium A to medium B, If their densities are going to be same, there is no bending, there is no refraction. If the densities are going to be different, then only there exists a bending of light ray at a particular angle. If you have taken that from water to air, it is going to be where the light is going to be entered, here into the water, here into the air. This is the case, you have to confirm and conclude that matter. Please have a look into the matter. This is very important concept. Thank you. Now you can go for next question. Please have a look. Yeah, if the refractive index of glass is 1.5, then the speed of the light in the glass is, yeah, you have to confirm that. So while you are going to talk about that refractive index, it is the ratio of the speed of light in vacuum to speed of light in the medium. So the refractive index is the ratio of C by V. Simply you are going to talk about that. C is the speed of light. You have to take that. What they have given in the given problem, they have given refractive index, and you need to calculate that the speed of light in the material. Please have a look. Refractive index is the one parameter which is related to the speed of light in a one material. Simply if we are going to talk about that, how many times it reduces the speed of light, if you are going to take that. While looking into the formula, you can understood very easily. Please have a look. Yeah, refractive index. If you are going to talk about that refractive index, it has been shown with mu. Therefore, mu is equal to, yeah, speed of light in air by speed of light in a medium. What they have given in a medium of glass, you have to take that in a medium of glass. Please have a look into that matter. Please, speed of light in air or vacuum, that is C, that is V. So the refractive index is nothing but ratio of C and V. What is your aim? You have to calculate that V. Therefore, V is equal to C by mu. We can understood very easily 1 by mu into C. You can take that 1 by mu. What is the mu value? Yeah, they have given mu value. So with the help of this, let us assume this is equation 1. With the help of this equation 1, what can you understood? Please have a look. It is going to be reduced speed of light. If you have taken that air medium and glass medium, does the speed is same in two cases? No. If you are going to have a look into the matter of rarer medium and denser medium, the speed of light is reduced. Nothing but the speed of light is decreased. Now, if you are going to have a look into the matter of that 1 by mu times speed of light is going to be reduced. Now, the refractive index they have given that 1 by 1.5. Suppose if you have taken that the refractive index of that water, it is going to be 1.33. So, 1.5 times it reduces, 1.33 times reduces whenever light enters from air medium to the water medium. What happens? Its speed is going to be decreases. So, simply refractive index is the significance of how many times that the light speed is going to be reduced. So, maximum speed of light is going to be 3 into 10 to the power of 8 meter per second. This is the maximum speed. If you are going to take that light in vacuum, it travels with this speed. In air medium also it is going to be traveling. So, if you are going to take any material, the speed of light is going to be less than that of this value. At the same time, if you know that refractive index, you can easily assess that, you can easily guess that how many times it is going to be reduced. So, refractive index is the one topic you can understood very easily. If you know refractive index, you can guess that how many times that speed of light is reduced in that medium. That is very simple concept and easy to guess that how the speed of light. Generally, whenever light enters from one medium to another medium, there exists a change in its speed. That is what you need to estimate, that refractive index of that medium is known, then only you can have that idea. Yes. So, in the given problem, you are going to know that, yeah, therefore, V is equal to C by mu. Yes, you have to find out that speed of light, you have to find out that speed of light in glass. Yeah, right. Now, if you are going to have a look, that is 3 into 10 to the power of 8 meter per second by 1.5. Now, you can easily cancel that, therefore, 2 into 10 to the power of 8 meter per second. You have to get this one. Yes, 2 into 10 to the power of 8 meter per second. Now, you have to look into another question. Please, let us have. Yeah, when light ray moves from air to a transparent medium, they have given angle of incidence and the angle of refraction are 45 degrees and 30 degrees, right. What is the refractive index of the medium? Yeah, if you know that the angle of incidence and angle of refraction, then you can able to calculate the refractive index of that material by using the Snell's law. Yes. So, okay, you can take that light enters from air to a transparent medium. What is the case? What is the case? You have to take that light enters from air to transparent medium. The transparent medium is either glass or water or whatever it may be. You need to find out that by getting the refractive index value. Please have a look. That is air to transparent medium, air to transparent medium, air to transparent medium. Yeah, that is the case. So, you can take, you will apply the Snell's law, easily you will find out that this is the case. Yeah, you have to consider this is the air and this is the transparent medium. This is the transparent medium. Now, it will enters, yeah, it will enters that angle of incidence is 45 degrees. The angle of incidence is going to be 45 degrees. With respect to normal, you will measure that 45 degrees. So, what is the angle of refraction? 30 degrees. Now, you can show that angle of refraction, it is going to be 30 degrees. What is your aim? You need to find out that where the light is enters, this is the refracted ray. This is the refracted ray, let us assume. The light ray which enters from first medium to second medium, you are supposed to calculate the refractive index of the second medium. So, what is the formula? What is the law which has been used for this problem? Snell's law, you know Snell's law, you know Snell's law. You will apply that Snell's law, it is very easy. So, this is the refractive index mu A, this is mu T. Yeah, mu A and mu T. Now, according to the Snell's law, easily you will find out that you will apply that Snell's law for that two medium, you will find out very easily. That is mu A into sin I is equal to mu T into sin R, mu T into sin R. Simply the Snell's law conveys the ratio of sine of angle of incidence to the sine of angle of refraction is equal to constant, that is refractive index of the second medium with respect to first medium. Simply you will take that sin I by sin R is equal to mu 2 by mu 1. You have to consider this formula. Now, if you are going to take that, yeah, so mu A is equal to 1, it is very clear. Therefore, sin I is equal to mu T into sin R. Therefore, sin I by sin R is equal to mu T. That is the case you have to consider. By substituting this value, you will find out that mu T. What is mu? Refractive, mu suffix T, that indicates refractive index of transparent medium. Now, easily you will find out that, yeah, if you are going to take yes, have a look into the substitution, that is sin I, they have given that angle of incidence is 45 degrees, 45 by sin 30 degrees, that is equal to mu T. Yes, you know very well about sin 45 and sin 30, you will easily identify and calculate that. Yeah, therefore, 1 by root 2 whole divided by 1 by 2, yeah, that is equal to mu T. So, you can easily find that, yes, if you are going to have a look into the matter, just you will find out that 2 by root 2 is equal to mu T. If you are going to take that 2 divided by 1.414, that is equal to mu T. Yeah, this is about 1.4178, you will take that. Yes, you will get this 1.418. So, it was approximated 1.42. Yes, final answer is the first one. Please have a look into the matter. Yes, let us take that another problem. Yeah, angle of incidence for which the angle of refraction, that is very, very important. You have taken that. Whenever light enters from one medium to another medium, say denser to rarer medium, the angle of incidence for which the angle of refraction is, yeah, please, the angle of incidence for which the angle of refraction becomes 90 degrees. Take this case. And if you are going to have a look, whenever that light enters, yeah, so yes, yeah, you will find out that this is the refracted ray, refracted at 90 degrees. Yeah, this is the angle of incidence. Please have a look. If you are going to incident the light ray from the denser to rarer, yeah, you have to consider this is the denser, this is the rarer. This is the rarer medium and this is the denser medium. Now, if you are going to have a look into the matter, it is the angle of incidence theta c at which the angle of refraction becomes 90 degrees. that incident angle is known as critical angle. If you are going to take for one material, its critical angle different. If you are going to take another material, its critical angle changes. Now, I am talking about this critical angle. I am going to be incident at a particular angle. This is the, we may take that. Other than critical angle, what happened? I have incidented the light, it refracted. I have increased that, then only there exists a refraction. There exists a refraction. This is about 90. Here you are going to increase the angle of incidence. You are increasing the angle of incidence. First, let us assume you are going to take that critical angle is small. Let us take that 20, 30, 40. Suppose this seems to be 45 degrees. I am going to increase gradually. At a particular angle, you will get that angle of refraction is 90 degrees. That is the case we have to confirm. I have taken, this is the first case, this is the second case. In first case, it was refracted from one medium to another medium. But in this case, what happened? Gradually, I am increasing that angle of incidence. If you want, I will take another question. Example, I have been incidented. Further I am going to take that at a particular angle, you will get this is 90 degrees. Please have a look into that three cases, first case, second case and third case. So, you are further increasing the angle, at a particular, becomes 90, the angle of refraction becomes 90, that is called critical angle. So, what can you define critical angle? It is the angle of incidence at which that angle of refraction must be 90, that is the condition. So, the angle of incidence for which the angle of refraction is 90 degrees is known as dash, angle of, that is correct, critical angle. So, simply you will understood, you will increase gradually. Here, from here, from here, from here, from here, from here. Here only I am getting, here only I am getting. So, here finally this is the critical angle theta c, very simple. I am increasing. At a particular, you will get, at a particular angle of incidence, you will get the critical angle, that is the case. Now, let us go for another question. It is a very simple question, you can understood very easily. An object 2 centimeter height is placed in front of an object 2 centimeter height. You will take that h naught is equal to 2 centimeters. That is object distance u is equal to 16 centimeter. Produces the image of 3 centimeter height. Okay. Height of the image is going to be 3 centimeters. Height of the image is 3 centimeters. Then you will find out that position of image. They have given that height of the image and height of the object. You are supposed to calculate that. Yes, please take that. This is the given data. Height of the image is given, height of the object is also given. The type of mirror is concave mirror, you have to take that minus. So, concave mirror has given. Now, can you take that magnification, magnification, you can take that magnification, that m is equal to hi by h naught, hi by h naught. If you are going to take that an object 2 centimeter height is placed at a distance of 60 centimeter from a concave mirror, which produces a real image of 3 centimeter height. The position of image is, you can find out that, yes, 2 centimeter height is given, is placed at a distance of 60 centimeter of a concave mirror, which produces the real image. Real image, you have to find out that the image has been formed in front of the mirror. That is the case we have to consider real image. Now you can take that V is equal to, you have to find out that V is equal to question mark. You need to find out that. What are the related formulas? So if you know that this M is going to be identified, that is height of the image. Yeah, you are going to get that 3 centimeter, 3 by 2. Yes, you can take that M is equal to 3 by 2. And if you know that M value, how you will find out that V value? Generally, if you are going to take that, the ratio of V and U is equal to M. So, we know that M is equal to minus of V by U. You know that M is equal to V by U. So, if they have given the values of V, they have the values of U and the values of Hi and H naught, you can easily find out that. Please have the substitution, that is 3 by 2 is equal to, you can take that minus of, yeah, you can take that image, height of the image is going to be taken as this is negative. So, this is minus height of image, which is going to be taken in the perpendicular direction. Now, you can take that minus 3 by 2 is equal to minus, you can take that V is equal to, it is going to be identified that V that is minus 16. So, you will find out that easily. Yeah. Now, yes, by the substitution you will find out that minus 3 by 2 is equal to what, that value U, that is of cancellation, it is going to be getting that V by 16. So, you can easily find out that yes, yeah, minus 24 centimeter. Please take the options, this is the correct answer. Have a look into that. Right. Let us go for another one. An object is placed at a distance of 30 centimeter from a convex mirror of focal length 30 centimeters. So, the image will form. Convex mirror, F is going to be positive and you are going to find out that V is equal to question mark. So, simply 1 by F is equal to 1 by U plus 1 by V. You can take that, yeah, the object distance has given, that is 30 centimeters in front of that. So, this is U is going to be minus 30 . Now, we will take that 1 by 30 is equal to, this is the object distance, U is equal to minus 30. So, minus 30 plus V. So, 1 by V is equal to 1 by 30 plus 1 by 30. So, V is equal to 15 centimeter, V is a 15 centimeter behind the mirror, it is going to be getting. So, which of the mirrors are used as a reflectors in the straight line? So, convex mirrors are used as the reflectors in the straight lines. So, let us have that. Now, we are going to discuss about that angle of incidence. We are about to discuss about what is angle of incidence and angle of refraction and all these things. So, thank you for your patience. Have a great day.